Hey everyone, so in this video I just want to take a moment to work on some harder questions for adding and subtracting algebraic fractions that you may encounter in your textbooks. So in the textbook I'm working through, this has its own chapter called Further Addition and Subtraction of Algebraic Fractions. So a lot of the stuff we're going to be doing is going to be quite similar to what we did in the previous video. We're just going to take it up a notch, especially for the second and third example in this video. Now let's get right into it. We want to perform this algebraic fraction subtraction. So we're going to go through in the same way, do what we've been doing up until now. We want to find the lowest common denominator. What's that going to be in this case? Well, it's going to be 30. This is the smallest number that both 6 and 5 go into. So what I want to do here, I'm working a little bit quicker because I assume everyone who's come here has watched at least the previous video in which I go through this stuff a bit slower. But we want to see, well, how can I get 6 to 30? I'm going to multiply it by 5, and I'm going to do the same to this entire expression up the top. And this will allow us to get to an equivalent fraction here. I'm going to do the same thing on the right hand side, except I'm multiplying by 6 to get me to another equivalent fraction. So here now I have 5 outside of 2x minus 3 on top of 30. Well, I'll leave them over the same denominator. That might be easier and it'll save us some time. And this, we're going to subtract 6 times 3 minus x, all over 30 here. Okay, now all that's left to do is just to expand. So give myself some more room and let's expand these brackets. So I'm going to use the expansion I've been doing so far. So the number outside the brackets is going to multiply by both the numbers inside. So 5 times 2x gives me 10x. 5 times minus 3 gives me minus 15. And here I'm get 6 times 3, that's negative 18. Sorry, negative 6 times 3. And I have negative 6 times negative x. That's a double negative, so the product is going to be positive. So that gives me positive 6x all over 30. And all that's left to do now is to just simplify. So I'm going to collect the like terms, similar to how we've done in the last video. And I want to perform the rest of the arithmetic to get my answer. So this is going to give me, when I add 10x with 6x, it gives me 16x over, whoops, sorry, I'm not finished. When I do minus 15 minus 18, that gives me minus 33 over that same denominator, 30. Okay. Let's move on to another example. This is where they start to get a little bit harder. That first one was just a quick one to ease you in, but this is where it gets a little trickier because you can see now our denominators, we've gone a step further. Our denominators are not just algebraic terms now, they are binomials. There are 2 terms here. So I want to think, well, how can I do this? And some of you may be stuck in terms of finding a lowest common denominator because there's no indication of what this could be. It's not like before when we had, for example, x and 2x, and I could just multiply this one by 2. These are completely different looking denominators. But let's just think for something for a second. I'm going to do this in the same way that we did in the previous videos, where I'm going to try to relate this to the things we've already done. So let's say I took 4 over 5 times, 2 over 3. When I have 2 numbers down the bottom, I can always find a denominator that satisfies both by finding the product of those two. So with these, for example, the lowest common denominator would be 15. That's a product of 5 and 3. Because any numbers, if we times them together, we get a number that both go into, which is what we want when we want to find a lowest common denominator. So what happens when we don't have any numbers that we can see on the bottom? Well, we can always find a lowest common denominator by considering, well, no matter what those numbers are, if I times them together, that will get me a denominator that both go into. And in this case, because we don't know what the numbers are, we're going to assume it's the lowest common denominator. So that lowest common denominator is going to be a product of these two binomials. Now this is a little bit tricky to think about, but if we look at how we've found these in the past, take this example for example. We had 6 and 5, right? And the lowest common denominator was a product of those two numbers. It was the smallest number that they both went into. We're doing the same thing here. The only difference is we just don't know what these numbers are. So we're just saying the lowest common denominator, this is a product of this and this. So if we think about this then, what would my left-hand side, so I have 4, and I have x plus 1, x minus 2. What would 4 have had to be multiplied? Oh, sorry, what would x plus 1 have had to be multiplied to get me to this denominator? Well, it's been multiplied by x minus 2. In the same way that 6 up here was multiplied by the 5. The same thing is being done down here. It's just that we're now multiplying the x plus 1 by another binomial to get us this denominator. So x plus 1 has been multiplied by x minus 2 in order to get this denominator. So we're going to have to multiply the top as well by x minus 2. Same thing with this one. What number would x minus 2 have been multiplied to get me a denominator of x plus 1 and x minus 2? Well, it must have been multiplied by x plus 1. So I'm going to do that to both top and bottom. I multiplied x minus 2 by x plus 1 to get me this thing down here. And I also, because remember I want an equivalent fraction, I'm going to take the numerator and multiply it by x plus 1 as well. And now I can write this addition over the same denominator. So I'm going to write 4 outside of x minus 2 plus 3 outside of x plus 1 all over x plus 1 multiplied by x minus 2. Now, if I wanted to, I could expand this, but there's absolutely no need. You can leave your answer as this denominator right here. You've shown that the lowest common denominator is just the product of those two. So what I have to do now is I have to expand, right? So I'm going to multiply my outside term by the two inside terms. That's going to give me, on the left, 4x. 4 times negative 2 gives me negative 8. Plus 3 times x gives me 3x. Plus 3 times 1 gives me 3. And that is all over x plus 1, x minus 2. And finally, all that's left to do is to simplify the top. I want to collect my like terms, and I want to add or subtract my remaining integers here. So 4x plus 3x gives me 7x, minus 8 plus 3 gives me minus 5, and my denominator is x plus 1 outside of x minus times x minus 2. That is my final answer. So I can break this down in the exact same way. Finally, we're up to our last question here. And what I want to do here is find the lowest common denominator. Now, once again, I have binomials down here, but that doesn't matter. And we're going to use a similar thing we did in the previous video. We have this squared happening here. So that means this left-hand fraction is the same as x minus 1 times x minus 1. So I can get my right-hand denominator to this one here just by multiplying by x minus 1. Multiplying that 1 on the right by x minus 1. So I'm going to do this times x minus 1, and it's an equivalent fraction I'm looking for, so I'm doing this to the top and bottom of my fraction. So my left one doesn't change, but my right one, my numerator, becomes 2 outside of x minus 1, because 2 is multiplying by the whole thing, this whole number, and that is going to be written on top of x minus 1 all squared. Now all that's left to do, in the same way we've done before, is now we just want to expand this one up here and then simplify. So this is going to give me 3 minus, so I have minus 2 times x gives me minus 2x, minus 2 times minus 1, I have a double negative, so I get positive 2 on top of x minus 1 all squared. And now I have a 3 and a 2 that I need to add, and I can't do anything with this negative 2x. That's just going to stay how it is. So I get 5 minus 2x on top of x minus 1 all squared. So even as these questions get even trickier, there is no need to fear. We are going through these questions in the same way we went through the year 7 fractions questions before we even introduced algebra. The concepts stay the same. I wrote them in the previous video. Please have a look. Just to quickly recap them, every single time we're finding the lowest common denominator, we're making equivalent fractions, then we are adding or subtracting the top. Now here there are a couple of extra steps. When we add and subtract, we need to expand, we need to collect like terms, all of that stuff, but that's the only way it gets harder. The procedure stays the same. As long as you stay true to that, you keep on that, practicing that type of method, then these questions, although they look scarier, will come as not as much of a challenge to you because you have the foundations. Thank you so much for joining me, and I'll see you in the next video.